Hello everyone. This presentation demonstrates our functional programming mini-project, developed using Haskell. The project is a tax calculator, designed to illustrate how key functional programming principles, such as pure functions, immutability, recursion, and strong static typing, can be effectively applied to solve a real-world financial problem in a reliable, maintainable, and scalable manner. This project was developed by the following group members: EG202041115, Poornima K. EG2020483, Samasthi H. EG2020424, Virajini M. EG2020427, Wahalathanthri W. Income tax calculation is a real-world problem where correctness and transparency are very important. In this project, we calculate personal income tax using progressive tax slabs and provide a detailed tax breakdown for each slab. The project supports interactive command line input, batch processing using CSV files, a REST API using a web server. All these interfaces reuse the same pure tax calculation logic. The project is organized into multiple modules to ensure modularity and testability. Data types. HS defines all the custom data types such as tax brackets, taxpayers, and tax results using algebraic data types. Processing. HS contains the core pure logic for calculating tax and slabwise breakdowns. Utils. HS provides small pure helper functions like safe, number parsing, and rounding. I/O handler. HS handles all input and output operations such as user input, file reading, and result display. Main. HS is the entry point for the command line application. Main web. HS and web server. HS are used to run the web-based version of the application. A key design principle of this project is the separation of pure functions and I/O. All tax calculations are written as pure functions, meaning they always produce the same output for the same input and have no side effects. I/O operations like reading input, printing output, and handling web requests are isolated in separate modules. This design improves correctness, reliability, and testability, which are important in financial systems. Now, I will demonstrate the interactive command line mode. When the program runs without arguments, it asks the user for their name and annual income. The input is safely validated using the maybe type, preventing runtime errors. After entering the details, the system calculates the total tax and displays a slabwise breakdown, showing how much tax is applied at each rate. The application also supports batch processing using a CSV file. In this mode, the program reads multiple taxpayers from a file, processes them using a pure data transformation pipeline, and outputs the results one by one. File reading errors and parsing errors are safely handled using the either type, ensuring the program does not crash. In addition to the command line interface, we have implemented a web server using the Scotty framework. The server exposes REST API endpoints that accept JSON input and return JSON responses. This allows the tax calculation logic to be reused by web or front-end applications without modification. Again, the web server only handles I/O, while all tax calculations remain pure. This project demonstrates several key functional programming concepts. Pure functions for predictable and reliable computation. Immutability with no mutable state. Recursion and higher-order functions such as map and fold. Algebraic data types to model real-world entities clearly. Safe error handling using maybe and either. These features make the system easier to reason about and extend. In conclusion, this project shows how functional programming in Haskell can be used to build a real-world financial application that is correct, modular, and maintainable. By separating pure logic from I/O and using strong typing, the system becomes safer and easier to test and extend. Thank